Hello, in this video I will be discussing the activity assay for the enzyme polyphenol oxidase. Dopamine hydrochloride is an irritant and environmental hazard, and so is sodium dodecyl sulfate, another reagent that you might use in today's assay. So wear your gloves and your goggles and your mask, and obviously all waste today will go in the toxic aqueous waste. The enzyme catalyzed reaction is displayed here. You see how dopamine is oxidized and the enzyme PPO accelerates this reaction, and the final product is called aminochrome, or dopamine chrome is an alternative name. Aminochrome has a pink brownish color. It starts out light pink, and then as time progresses, older assays have a more dark brown color. And the light absorption is strongest at a wavelength of 480 nanometer, and the molar extinction coefficient at this wavelength is 3,300 in units of molarity to the power of -1 centimeter to the power of -1. Lambert-Beer law describes how absorbance depends on the molar absorptivity value and the concentration, as well as the path length of the cuvette. The path length is always going to be 1 centimeter, so you see how the units cancel out with respect to the centimeter of the molar absorptivity coefficient, and the molarity cancels out with the concentration of the aminochrome. So absorbance values have no unit. At a different wavelength, the molar absorptivity value would be different, and that means the absorbance value would be different. Since aminochrome absorbs light so strongly, we can monitor the reaction by following the absorbance increase at 480 nanometer. As aminochrome forms in a time-dependent manner, the absorbance peak at 480 nanometer with the strongest absorbance value at 480 nanometer will increase over time. And your goal in this experiment is to measure the rate of absorbance increase at that selected wavelength over a time interval of a minute. Absorbance increase over time is a very technical way to express how active an enzyme is. If PPO is very active, or you added a lot of polyphenol oxidase to your assay, then the absorbance will increase faster over time, or the absorbance will increase faster, and therefore the rate delta A for absorption over time is going to be very high. However, as chemists, we want to express the activity of the enzyme in different units. Micromolar per minute is the preferred unit. This is also known as an international unit. In the video on how to analyze your enzyme activity assay, you will see how this unit conversion formula is applied to all your individual assays. Here you see the typical setup of one of these enzyme activity assays. You need several different types of pipettes, pipette tips, cuvettes, Kim wipes, and all your reagents need to be carefully labeled. A single assay contains the sodium phosphate buffer, the substrate dopamine, and distilled water. These reagents can be pre-mixed, but as soon as you add the banana extract, the enzyme will start to catalyze the reaction. That means you can't prepare cuvettes ahead of time, because as soon as you add the banana extract, the reaction is catalyzed and you need to be ready to start the measurement immediately. Also, you should test out how much banana extract is the best possible amount to conduct assays. So just start with one single assay and then evaluate the result. Here you see the practical steps with the water, the buffer, and the dopamine solution laid out in different beakers. I already conducted a few assays, so you see some colored cuvettes. And in that first cuvette, I already have the 1000 microliter of buffer. Then I'm preparing my 1000 microliter pipette, removing an old cuvette. And with the 1000 microliter pipette, which I pre-wet, I'm mixing in the water, and it was the 700 microliter that I added. The dopamine is next. And then I'm already putting the parafilm to the side so that I save time, because the only ingredient that is missing now from my assay is the banana extract. So I have the nano drop instrument open and ready to go. In this experiment, I used banana extract from a larger tube. It's always important to make sure that a crude extract is well mixed before you take a sample out of it, because it's a more heterogeneous type of solution. Then I'm trying to be speedy but not too hectic, but mixing is really important for these assays. And then as soon as I'm putting the cuvette into the machine, I'm pressing on the save button. I get to the save button because I already pressed measure before hitting the save button. And you find all these screenshots here and more details in the protocol, which I posted on Blackboard. The instrument will take a series of recordings, and after the minute, this is the type of result that you should get for a successful assay. You can see how the dopamine formed aminochrome, or you can see how the dopamine was turned into aminochrome because the absorbance peak increases, and I'm able to catch the linear rate. I'm not taking all the data points here because I really want to get the tangent where the rate is still linear. Here you see another example where it's more difficult to catch the initial rate. The reaction starts to level off much sooner, and I can't take all the data points. The other extreme is not having enough banana extract so that you get very weak and noisy data. So for example, if I don't add any banana extract, or if I diluted the banana extract too much, and in this case, you can average over all the data points, because basically you're just measuring noise and maybe a tiny bit of the background reaction on how dopamine is turned into aminochrome even without the presence of the enzyme. Your goal of today's experiment, or your goal of the PPO activity assay, is to collect a series of PPO activity assays in which you vary the amount of the diluted banana extract. You can run individual assays, as shown here, where you always mix the buffer with the dopamine and the water, or another strategy, which is an alternative, is to first make an assay mixture. There also is an optional part of this experiment in which you experiment with the activator sodium dodecyl sulfate, SDS, or in addition to, and that might be the more interesting experiment actually, is to check out what happens if you have an inhibitor like ascorbic acid. And in this experiment, or in this table, you can see how in order to really vary the ascorbic acid concentration in a large range, strategy is to pre-dilute the ascorbic acid. Make a serial dilution where you always take 900 microliter water and 100 microliter of the ascorbic acid stock solution. You mix well, and then you take from this 0.1 molar solution to make the next dilution and then the next. This way you can cover a much larger concentration range in the experiment. So please check out the protocol of the PPO activity assay experiment and prepare your lab notebook before you come to your experimental session. Till then, and have a good day. Bye-bye.